Hello. Can anyone confirm if audio etc. looks fine before we get started? Hello, hello. 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 Am I audible? Okay, audio works fine. Thanks, Dushyant. I think let's get started. Like people in the chat, like how many problems were you guys able to solve today? I think like contest was a bit harder than typical Div 3. Okay, video is lagging a bit, not sure what's going wrong here. Like, I hope it's fine now. There's like essentially I am testing stream kind of like this. Like I was planning to participate in Blitz Cup and was testing like if everything works fine. Like so that's why we have this stream today. So yeah, I think that's where we are. People in the chat, like how many problems were you guys able to solve today? Like I'm not sure. Like I do want to start YouTube, but I do get quite a bit of was involved with more stuff. So yeah. Yeah, I think let's start with today and let's see how frequent I am again now. So yeah, like the problem was typically hard. I did found it typically harder than Div 3 problems. Most of my time was stuck here and still could not get an AC on G. And I haven't really seen H, so that's where we are. I think I will mostly discuss A to F, and that would be one. So yeah, I think like now let's get started and let's see what the problems are. So first problem says you are given n positive integers a1 to an. Please determine if it is possible to select any number of elements in A so that their product is 67. Note that you may not select zero element as product of zero element is not defined in this problem. So it says we are given up to 5 elements and we have to check how many of them form 67 as the product. So there are many ways to do it. One of them like can be like you can try to form all the pairs which like all the elements which are of check if 67 exists in the element or not, or you can check do you have two elements in the array with product 67 and so on. That can be one way to do it. You will have to write probably 5 for loops or something like that. Or another solution is realizing that like 67 is a prime number. Eleven. The crucial observation here is like 67 is a prime number. So like you can write 67 as a product. The only possible way is like to write it 1 into 67 into 1, so on like this. And if you have to write it like this, then you can notice that it's like basically there is no other way to write 67. Like there are no two numbers A and B such that A is 60, their product is 67 and one of them is not equal to. Both of them are not equal to 1. So that's the crucial observation. And now you can notice that checking 1 into 67 into 1 into 1 is as good as just checking 1 into 67 into 1, or probably like this. So like the problem boils down to just check if 67 exists in the array or not. 67 exists or not. And that was problem A. Like if I have to jump onto the code for this one. You iterate over all the elements. If 67 exists, you mark it as true and then you print true yes or no. Another way can be like notice that all the numbers are from 1 to 67. You can look at the maximum of the array and then maximum should be 67, and that's problem. Any questions here on this problem before we jump on to the next one? So I think this was the first problem. Okay, the next problem is you are given a permutation A of length n. You can perform following operation any number of times, possibly 0. Select an index I and swap AI and A into 2i. For example, 1, 4, 2, 3, 5, you can swap A2 and A4 to make it 1, 3, 2, 4, 5. But you cannot swap A2 and A3. Determine if it's possible to make A sorted in increasing order. There are a few crucial observations here. One of them is like A is a permutation of length n. So how does a sorted permutation looks like? Basically, permutation means that all the numbers from 1 to n appears at least once. Appear once. So how does a sorted permutation will look like? A sorted permutation would be nothing but first element would be 1, second element would be 2, third element would be 3, fourth element would be 4, fifth element would be 5, and so on up to n. This is our sorted order. Now let's see how does like this swapping works. You can swap 1 with 2, first element with second element. You can swap second element with fourth element. You can swap 4 with 8 element. You can swap 8 with 16 element. Like these are the possible permutation sorting ways you are given that are given to you. Now the important question is, can you swap 1 and 8? Let's say we can swap 1 and 2. We can also swap 2 and 4. Can you swap 1 and 4? Looks like possibly no, right? Because you can swap only 1 with only 2 and 4 with only 2, right? So now here is what you can do. Let's say the array is x, y, some dash, and some z. Let's first swap 2 and 4. Because 2 and 4 swapping is allowed. Then your array would be x, z, something, and y. Now you can swap 1 and 2 again. Because swapping 1 and 2 is allowed. So you will end up with z, x, something, and y. Now you can also swap 2 and 4 again. You will end up with z, y, something, and x. So after performing these three swaps like this, if you observe this and this. You can see that 1 and 4 has essentially changed their position and everything else is at the same position. So although you are allowed to only swap 1 with 2, 1 and 2 and 2 and 4, but we have figured out a way where we can keep 2 same and after some set of swap we can also swap 1 and 4. So this is the whole idea of this problem. If you can swap 1 and 2 and you can swap 2 and 4, then you can also swap 1 and 4. And similarly, you can also extend it to, because you can swap 4 and 8, you would be also able to swap 1 with 8 and 2 with 8. Just that the number of swapping will keep on increasing, but it's technically possible. So this is the whole idea of this problem. So what you can do is, you can essentially, for example, 1, 2, 4, 8, 16, you can essentially swap any element in this set with any other element. There are no restrictions from our problem. Any questions so far? Yeah, why if I am allowed to swap 1 and 2 and if I am allowed to swap 2 and 4, I can also swap 1 and 4. That's the first observation. Then if you keep on extending this idea further, you will realize that you can also swap 1 and 8, you can also swap 2 and 8, and essentially any pair here. Like this is the first important observation here. Any questions so far?
Sorry, folks. I'm so sorry. I cannot.
So the next idea is, so once we have this observation, what you can try to do is you can try to figure out basically for each element, for each index, find the smallest index. It, like basically, let's call, or let's probably look at this first like this. 1, 2, 4, 8, 16 is one pair over here, which you can swap however you want. Then you also have 3, 6, 12, and so on. 24 and so on. Then you also have 5, 10, 15, 20, and 5, 10, 20, and so on. You can also see, like, try to form classes like this: 7, 14, 28, and so on. So on, like this list keeps on going. This will be swappable with 40. This next would be 56, and so on. Like these are the indexes you can swap in however way you want. So the main idea is, for each index, figure out what is the smallest number we can go to. For example, 16, if you keep divided by 2, 8, 8 can also be divided to 4, 2, and 1, so on. For 24, also find the smallest number you can get by continually dividing it by 2, 12, 6, 3. So the idea is, for each element, find the smallest index that we can go to. smallest it can go to. And this is where we are. Like for each element, find the smallest index it each can go to. And you should notice that, like basically, if an element is at I, and if you have AI, then both of them should belong to same smallest index. So like if you have I at AI, keep dividing it by 2, find I by 2, find I by 4, find I by 8, so on. Find AI by 2, AI by 4, AI by 8. And at last, whatever number you get, they should be same. Like because like they like essentially that's the whole idea over here. This is one way to do it. Or another way can be like, for example, each AI, you can see like how you can send ith element at AI. Can be sent to ith element can be sent to 2i, ith element can be sent to 4i, ith element can be sent to 8i, ith element can be sent to I by 2, ith element can be sent to I by 4, ith element can also be sent to I by 8, and so on. So you can keep trying all of these permutation and see where what is the right. If one of these element is if one of these elements is equal to AI, then we will be able to place AI at correct place. At correct place. And that's the whole idea for this problem. Like I can try to provide like the samples code here. Let's take array A as input. This is where we are. Let's keep a variable is possible. If it remains true, and let's find the set. Like for I, what all places we can send it to. We can keep send it to all j less than I. And we can keep dividing, we can keep multiplying j by 2. Or you can send it to all the possible numbers less than I. As long as j I is divisible by 2. If AI is present in this set, then it would be possible to move it to the right place. Otherwise, this is possible equal to false. So I think this was the whole idea for this problem. Okay, like people in the chat, like what were your ideas here? Okay, I think, oh, I complicated. Rindam says, oh, I complicated this by sorting these groups by two multiples. I think that's the most tempting idea to solve for, but it's due 3B, so you should not expect like this would be this hard. Like someone in the chat says, like, a second, Dushyant says, or can we also check XOR of I and AI should be 0? I'm not sure like why that would be the case. Like if you have to take XOR of I comma AI, then I think that essentially boils down to taking XOR of all 1 to n and taking XOR of all A1 to AN. That will always be 0, right? Because A1 to AN will also contain all the numbers at least once. Or if you are claiming that XOR of I and AI should be 0 for all pairs, then that will also not be the case. So I'm not sure like what the idea is, but I'm not sure if XOR will work here. So this was problem B. Any questions, anyone on problem B before we jump on to the next problem? So otherwise I will move to problem C. So any simple ideas anyone has on problem C? Like I ended up doing DP, but it's C problem, so I don't think DP is expected here. Any greedy ideas anyone has on problem C? Okay, just do changes by 2. Changes by 2, you mean like number of pairs that are not adjacent? Like I did DP in the contest, but okay, Neil has DP. Okay, the way people are doing is like they are finding. Okay, they are finding consecutive groups, which doesn't hold true, and then they are dividing it by 2. Looks interesting. Hmm. Okay, yeah. So one way people have solved. Okay, let's first read problem C. Consider the following cube D where numbers x and 7 minus x lie on the opposite side. A sequence of integers from 1 to 6 is called die-roll sequence if it satisfies the following condition. All pair of adjacent elements lie on distinct side of the cube. And for example, 142 is a die-roll sequence. For example, 1 would be here, 4 would be on this side, 2 would be here. While 3463 is not, because 3 and 4 are not adjacent. 3 is on this side, 4 is on the opposite side. Additionally, 2 to 4 is not a die roll sequence because 2 and 2 are on the same side. Given a sequence A of n integers from 1 to 6, you can perform the following operation any number of times, possibly 0. Select an index I and an integer x and then change the value of ai to x. Please determine the minimum number of operations required to make a die roll sequence. Any questions, anyone, on the problem statement itself? What is problem asking us to do? Before we jump on to the solutions here. Okay, so essentially problem statement asks us to first let's see what is a die roll sequence. Die roll sequence is like this. Essentially, you have a cube. I think it was right. Let's say here you have 1, you have 2, you have 3. On this side you will have 5. On this side you will have 4, and the opposite of 1 would be 6. So, like, first let's look at the number at the top, which is 1. Now let's roll this drive to make a nearby number at the top. Then the die will look like this. You will end up with a die like this. Now you have 3 at the top, 6, 4 at the bottom. You have 2 here. You have 5 on this side. You have 1 here, and you have 6 on the other side. So the next number is 3. Now you can try to keep rolling it sideways and you write all the numbers down. And the whatever sequence you get is known as a valid die roll sequence, is what they have said. Or another way to put at it is, or if you observe the example, another simplified way to say that our sequence A1, A2, A3 up to AN is die roll if no two nearby elements are equal. Are equal. That would be the case, then you wrote down the number without even changing the die again. Or no nearby numbers sum up to 11, sum up to 7. This would be the case when you simply change the die to put the number element at the bottom to the top. So what you have to do at each time is whatever number is at the top, rotate it to the one of the sideways and keep doing it. So this is the problem statement for us. And the idea here was like probably to figure out what is consecutive set of pairs which are incorrect. So for example, 1, 2, 5, 5, 2, 3, 3, 4. Let's say this is one random sequence here. 1, 2, 5, 5, something like that. Then try to find out each set of elements which are incorrect. Like this one is right. There are no problems here. This is the longest sequence which is incorrect because every adjacent number is here. These two are equal and here they sum up to 7. So that's not possible. 334 is also one incorrect sequence. Here you didn't change anything, and here you move to the element at the bottom. 1 is again correct. 225 is again incorrect sequence. So now in this sequence, the main idea is you can change every second element to your favorite number to get a die roll sequence. So let's say we can change this to these two elements. We can change this. For example, we can change this to one element which is not equal to 2 and 5, which is 1, and the problem would be good. Here you have to change this as well. Here you can change to any element which is not near 3 and 5. For example, you can again change it to 1. 334. Here you can change it to something, let's say 1 again, which is not near 4. 4 and 1 is good. 1 and 2 is good. 2 and 5. Here also in this element, you can change it to something which is not near 2 and 5. For example, let's say 1. So that's the whole idea. Like find each blocks which are either you have ended up with the same element or you have ended up with the opposite element. That length by 2, just do sum of this length by 2, and that will give you the required element. The whole idea is like, for example, if you have a block of 5 elements which is not correct, then you can change element at 2 and 4 to get the required sequence. Or if you have a block of 4 elements that's not correct, then you can change element at 2 and 4 and so on. And that's the whole idea here. Any questions so far before you jump onto the code here? So I think this was the main idea here. So let's probably jump onto the code now. Like, and then either current element is equal to the next element, or let's say current element is C. Or current element is equal to the opposite of X. In that case, you have a problem. You increase length by 1 IDX plus 1. And whatever block size you have gotten, you have to add its half to the answer. So this is problem C. Any questions, anyone, before we jump on to the next problem? So this was problem C. Let's move to problem D. It says absolute cinema. There is a hidden sequence a1 to an of n integers. It's guaranteed that every element is less than 1000 for all 1 to I. Let's define function f of x as ai sum of all ai multiplied by difference of I minus xi, some weird sequence. We are given values of f1 to n. Please determine values of a1 to an. It's guaranteed that values of a1 to an can be uniquely determined. And important concern, it says n is between 2 to whatever value is it, and all the values are between 1 to 10 to the power 14. And it says that the answer always exists. So any ideas, anyone, on how did this solve this problem? Okay, so the main idea here was like, first let's say what is problem statement for us. Like we have some elements a1, a2, a3, a4, a5, a6, and so on. Right? Now we define a sequence, for example, S1. Like which would be like this: 0 into a1 plus 1 into a2 plus 2 into a3 plus 3 into a4 plus 5 into 4 into a5 plus 5 into a6. This is what S1 is. Now let's also write what S2 would be. If you plug in the formulas from the problem statement, it would be like this: 1 into a1 plus 0 into a2 plus 1 into a3 plus 2 into a4 plus 3 into a5 plus 4 into a6. Let's also try to write down S3, which would be 2 into a1 plus 1 into a2 plus 0 into a3 plus 1 into A4 plus 2 into A5 plus 3 into A6. So like there are way too many variables here. But if you see, not a lot of things changes between here, these two values. Like every coefficient either increases by 1 or decreases by 1, nothing more. Here also not a lot of things changes. Every coefficient increases by 1 or decreases by 1. And like that's the main idea for this problem. Like you have to first write it like this and see what is the coefficients here. Or if I have to fill in a table like this, coefficient of A1, coefficient of A2, A3, A4 and so on. In F1, it's 0, 1, 2, 3 and so on. In F2, it's 1, 0, 1, 2 and so on. In F3, it becomes 2, 1, 0, 1 and so on. Now, if you focus on what is happening here, if we focus on I equal to x equal to 2, or essentially index 2, for all the element before it, it keeps on decreasing by -1. And all the elements here, sorry, it keeps on increasing by +1 here. And all the elements here, it keeps on decreasing by -1. And earlier it decreased by -1 and then it increased by +1. Or probably the another way to realize over here was, let's look at what 2 times F2 is. Let's say what is 2 times F2? Here it will become 2. Here it will become 0. Here it will become 2. Here it will become 4. And let's probably populate more numbers here. The next element here would be 4, 3, 2. And this element would become 6. And if you notice, this 2 is nothing but sum of these two elements. Sum of these two elements is 2. Here it doesn't hold. Sum of these two elements is 2. Sum of these two elements is 4, which is the number in white. Sum of these two elements is 6, the number in green, and so on. Essentially, the idea becomes, if you look at 2 times Fi and Fi minus 1 plus Fi plus 2, like all coefficients here are same. Same except for Ai. Did anyone realize why this is the case here? Because the moment you realize this, our problem will become a bit easier. Any questions, anyone? Or if I have to look at some arbitrary I, and let's say this is Fi, this is Fi minus 1, this is Fi plus 2. Here it will be 0, here is 1, here is 1. The sequence here is 1, 2, so on. Here also, like, the sequence would be like this: 1 2 3 and so on. Here it would be 2. And you can notice that 2 times of this will become 0, 2, 4, 6 and so on. 2, 4, 6 and so on. And this element is essentially equal to sum of these two. 4 is sum of these two, 6 is sum of these two, same on this side. So essentially, if you look at, by analyzing this, you will can reach to the conclusion that f of I plus 1 plus f of I minus 1 is equal to 2 times f of I plus 2 times of AI. Like, this coefficient you can compare by looking at this. If you look at fi plus 1, fi minus 1, both of them have coefficient 1, but for fi it's 0. And this is quite important equation for us, because this directly gives us a formula to find value of AI. You can say that AI is equal to move around fi plus 1 plus fi minus 1 minus 2 times fi divided by 2. So using this, you can find all I equal to 2, 2 and minus 1. Any questions, anyone so far, before we jump on to the next problem? So once we realize this, we can find all 2, 2 and minus 1. Then we can use the formula of f1 to figure out an, and we can also use formula of fn to figure out a1. Like, once you know every element, you know that f1 is nothing but 2 times a2 plus 2 into a3 plus 3 into a4 up to n minus 1 times an. You can subtract all of these terms, divide by n minus 1, and you will get an, whatever element you want. And same, you can do the same with fn to figure out a0, a1. So this was the idea for the problem D. So given element, let's say f, and we have to find a. First, look at all the middle elements. Half of this is our AI. Once you know this, you can take f0 and then multiply all the elements from 1 to n minus 1. Whatever element you would get, you can divide this by n minus 1 to get the last element. Now you can also take absolute value of all the elements with the last element. This will give you a 120. Now you can print all the required numbers, and that would be a solution. Any questions, anyone on problem D before we jump on to the next problem? So let's move to problem E. Idiot first says there is a binary tree of n plus 1 vertices with vertices labeled 0 to n. 0 to n. At most, one letter can be written on each vertex of a tree, and all vertex initially have nothing written on them. The root of the tree is vertex 0. In the tree, vertex 0 is the parent of the vertex 1, while all the other vertexes have either 2 children or 0 children. Bob is lost in one vertex of the tree and wishes to escape the tree by reaching vertex 0. This is very easy for most people with, let's forget it. However, since Bob he created an array, a new way to traverse the tree. Like essentially, you have given a tree, you have to go to the 0th vertex here, and you know who is the parent child of the each element. But Bob has its own way to traverse the array. For each element, if nothing is written, if it's the leaf, then you will go to the parent. Let's create a tree. If vertex is the leaf, Bob always moves to the parent, otherwise the check next few condition. If nothing is written on the tree, Bob writes L on the vertex and moves to the left child of the tree. If L is written on the vertex, Bob overwrites it to R and moves to the right child of the tree. If R is written on the vertex tree, Bob erases it and moves to the parent. It takes exactly 1 second for Bob to move to an adjacent vertex, so Bob will take exactly S seconds to perform H moves. It can be shown that regardless of which vertex Bob starts on, Bob can reach 0 in a finite move, possibly very large. We don't know who proved it, but surely it can't be Bob, but it's definitely proven. Now we have to find for each vertex how much time it takes to reach to the parent, reach to the 0. So let's see how the procedure looks like. Let's say our tree looks like this. 1, and 0. We want to reach here. And let's say we are at this vertex. Since nothing is written here, what Bob will do is Bob will write L and move to this vertex in 1 second. And since this is a leaf node, in the next second, Bob will move to the parent again. Now Bob sees that L is written over here, so he will write R here and he will move to the right child. And since nothing is written here, Bob will write L and move to the left child. Since L is a leaf node, Bob will move to the parent. And since L is written here, Bob will overwrite it with R and move to R right node. Since this is a leaf node, Bob will move to the parent. And since R is written here, Bob will remove it and move to the parent. Since R is written here, Bob will remove it and move to the parent again. And here you have reached the required location. So overall, how many moves it took? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Total 9 moves. So this is a procedure that Bob is following up. Any questions, anyone so far? So now we have to probably use DP on tree here. DP on tree ideas. Let's say for each, let's say this is node U. You have L, you have R. For each node, figure out DPU means all the elements are empty, like there's nothing, no character is written on each of them. Time taken to reach parent. Let's say this is P of U. DPU is time taken to go to the parent of U. Like essentially, let's say we know how much time it takes. If you start at L, you move something in the L and then you go to the parent of L. Similarly, if you know, like if you start at R, how much time it would take so for you to move whatever you do in R and then go to the parent. And what we want to find is like you started at U, how much time it takes for you to go to the parent of U. Let's first figure this out. Then the idea is when you start at U, you will go to the parent of U, then you will do something, then you will go to the parent of U, then you will go to the grandfather of U, grandfather of U, and so on. So that is the main idea. And if you closely observe what is happening at U, you were initially at U, nothing was written on it. You took 1 second. You took 1 second to write L here and go to the right child. Then you will do something here, and in DL second, you will go back to the parent. Once you are at the parent, you will change that L to R and you will go to the right child. Then you will do something here and then go to the parent again, which would be your DR again. And then since you have R written over here, you will erase it and you will go to the parent here. So plus 1 again. So overall you can say that if you start at DPU, the time would be 3 plus DL plus DR. Any questions, anyone on this equation first? This is like if you are at U, nothing is written here. How much time it takes to go to the parent of U? You can recursively find it if you know how much time it takes to go to L and come to the parent again. If you know how much time it takes to go to R and come to the parent again, then you take additional 3 steps. You are at a node U, you go to the left child, then after some time you come to L node again. Then you go to right child. After some time you come to the same node again. And after that you go to the parent of U. So 3 steps, once to go to L, once to go to R, then go to the parent, and the time you have to take from how much it takes to for you to come back from L to U again and R to U again. Any questions, anyone, on this idea? And then the next idea is, once you know how much time it takes for each node to come to the parent, let's say all, if you start here, let's put some number here: 1, 2, 3, 4, 5, 6, 7, 8. If you start at 8, then you will take d8 time to go to the parent of 8, which is 4. Then you will take d4 time to go to the parent of 4. Then you will take d2 time to go to the parent of 2. And then you will take d1 time to go to the parent of 1. So this is your way to solve this problem. First, you figure out for each node how much time it takes to go to the parent. And then if you start from some node, you have to first go to the parent, then go to the parent of parent, grandfather, then great father of grandfather, and so on. So you have to do one more DFS here to figure this out. And I think this was the whole solution for this problem. And if so, that's where we are. Let's first take graph as input. If U is a leaf node, then whenever you reach here, within 1 second, you will go to the parent. Others first find the result for all of the children. Let's find all the children here. Recursively find the answer for R. Recursively find the answer for U. Your U is 3 plus TPL plus TPR. Now if you have to find an answer, you can do the DFS again. And you can pass what is the sum of all the elements from root to the current node. How much time it takes to go to the current node? Let's also find the answer for all the children. Or if you don't want to pass to the current node as well, that's fine too. The answer to go from U to the parent is first you have to from U go to the parent of the U, and then from you take how much time it takes from parent to the root node. Now run this for all the children of U as well. Now print answer for all 1 to n. So this is the idea for problem E. Any questions, anyone? So this was problem E. Okay. Yes. Any questions? Anyone on problem E? I think here I'm discussing the problem of today's code forces round, which completed around 1 hour ago or so. Wait, 1 second. I think I can take questions after I'm done with discussing the problems. One more problem is remaining. Okay, I think probably the question was for cracking OA of nice companies, in which context, till which problem do you need to become comfortable solving? So I think like the definition of nice changes from person to person. But yeah, I think I would probably say like the first three problem of the lead code contest should be okay for a lot of companies. Okay, if you have raised the leaf, you should not find out its children again. So yeah, I think this is where we are. Like contrary to what people believe, like you strictly don't need code forces for it. Like the way I put it is like if your goal is to target some companies, then more often than not, like you will get faster results if you target lead code. Code forces, you need to spend a lot of time. Like the initial learning curve is quite high, and you will end up with the same result. Like what people have seen is like with code forces, like it's way too if you are done with code forces, it's way too easy to solve lead code problem. But for probably some companies, like I don't know what the percentage of companies is, but you can try with lead code only. So this was problem E. So the next problem would be parabola independence. Yeah, I should have changed approach for F once I noticed click solving wasn't possible. Yeah, like click is too tempting idea over here. And probably the way I would have, if I have to solve it for click, what I would have done is for each element I have. remove I from the array, and all the elements that are dependent on I from the array, then probably use cactal here. Cactal also has a click solution randomize or something like that. I don't know what the time complexity would have been, but that would have been the idea. But yeah, you definitely not don't need click for problem F. Okay, I think F is the last problem we would be discussing today. So let's try to wrap it a bit faster. Like basically, if you have to solve for click, then you have to probably search for some randomized library codes for it. And Cactal has one, if I recall correctly. You are given a set of n quadratic functions where f of I is ai x square plus bix plus ci. Two functions f and g are called independent if f of x is not equal to g of x for all x belongs to real number. Also, a set of functions g1 to gk is called organized the two if the two functions are independent for all I up to 1 to n. For each I, please find the size of largest organized subset of f that contains fi as element. So first, what it says is like we are given a lot of parabolas, and we have to find for each element I. You have to definitely choose I and find out some more parabolas such that none of the parabolas intersect. So, like for example, if I is one of the valid parabola, you have must choose I. Then this set will look something along the lines of this. Some more downward parabolas, and then some upward parabolas. Like this is how your ideal solution will look like. If you must choose, let's say, one of the downward parabola, you can choose some more parabolas which are below it, some more downward parabolas which are above it, and then some upward parabola. You cannot have one more downward parabola after choosing an upward parabola, otherwise they will intersect somewhere. So I think this is the main idea I had for solving it. I will solve for downward parabolas, and the solution would be similar for upward parabolas as well. Like, let's first figure out whether two parabolas intersect or not. We know that two parabolas will intersect when like their equation is exactly equal for some element x. Now all we need to do is, does there exist some x here? Then you can rewrite it to like this. Let's rewrite this to like this. Like basically move all the elements on one side and make it 0. And if you transform it, it looks like this. I think today I am discussing Codeforces round problems, which happened 1.5 hours ago. Now, if a is not equal to 0, then this is a quadratic equation. And you know, like a solution for quadratic equation looks like this. Minus b plus minus root of b square minus 4ac divided by 2a. So, which will essentially become Like we need to just check if b square minus 4ac is greater than equal to 0 or not. Because in that case, this term would be positive and you will get some x. Or if a is equal to 0, then equation becomes bx plus c. Then if b is 0 and c is also 0, then whatever you choose, like these are essentially the same equations. Or if b equal to 0 and c is not equal to 0, then these will never intersect. So like this is the first intersection function that we have to write. Like given two parabolas, we have to check whether they intersect or not. Let's take the difference of all the coefficient. If a is 0, b is 0 and c is 0 means both of the parabolas are exactly same. So you just return true. Otherwise, if a is 0, b is equal to 0, then like these are some parallel parabolas and the result is false. Otherwise, b square is greater than equal to 4ac, then they intersect, otherwise they don't intersect. So we have first computed result of all the pair of numbers and saved it somewhere. So now we can look at Eij to figure out whether ith element intersects with jth element or not. So now like the main idea was, let's solve for the downward parabolas. Let's first look at downward parabolas. Downward parabola, each of the parabolas will have a maximum value. Let's figure out this maximum values and sort them. Let's figure out the maximum value of this downward parabola and sort these parabolas based on this maximum value. I think I'm back. Can anyone confirm if I'm audible or not? A momentary disconnection existed. So I think now once you know you have sorted all the parabolas. For each parabola, you can figure out how many maximum parabolas below it you can select. Like basically, you can run it like, for example, you have selected this parabola and you have selected this parabola. Then next parabola should be lower than this. This would again be a DP idea. Similarly, for the parabolas above it, you have to do the same. Just that here you have to also take some upward parabolas with you as well. You can basically, let's say this is the maximum parabola you have chosen. For the parabolas above it, you have chosen this as the maximum parabola, and then you are free to choose all the parabolas that are above it. And again, it would again be some DP idea over here. So I think a lot of details need to be figured out here, but essentially this was the idea. First, I have figured out what all intersection points exist. All the upward parabolas and downward parabola, figure them out. Sort them based on like the maximum value of mean value. Like essentially, this is some equation you can figure out here. Like essentially, the equation is like this. These are the minimum values. Rather than dealing with floating point, I just multiplied both of these by x1 and x2. This is what you can do. Like if it's downward parabola, multiplying by two negative number is still multiplication by positive. Sorted them based on the decreasing value of the maximum value. Now for each value, we calculate how much element below it you can select. So this would be 1 dp again. You pick an index I. If you do nothing, you can choose one. Or you choose an element which is decreasing index plus 1. You have to find it in decreasing value of 1. So this will give you, for a given parabola, what is the maximum number of parabolas below it you can select. So then you have to run dp2 as well. Similarly, you can find for all the upward parabola using the same function, each parabola, how many parabolas above it you can find. Once you have done it, what you can do is like you have to find for the current downward parabola how many parabolas above it you can select. One way is if you do nothing, you just select upward parabolas. This is upward parabola here. Then find any upward parabola that you can, which is non-intersecting, and you simply add +1 to this value and we are done. Or you choose one parabola above the current one, which already includes some of the upward parabolas, and update it here. And total number of parabolas you can find using element I is number of parabolas you can choose below it, number of parabolas you can choose above it. Ith element includes ith parabola always, so -1 to reduce double counting and print the values here. So I think this was the main crucial idea over here. Couple of nested DPs, but that's where we are. Any questions, anyone on the core idea? Like I didn't really went into all the implementation detail, but this was the crux of this problem. Like you have to abuse the fact that why the problem statement has given us parabolas and nothing else. I think for line, it would be just counting number of parallel lines. 1 second. Looks like I messed up somewhere something. I think while trying to simplify it, I messed up, but yeah, I think this was the original code. Here I tried to solve it using upward parabola, not the downward parabola. So, any questions, anyone related to this contest or something else? I think I plan to wrap up the stream if there are no questions. Intersection here. All the upward downward parabola, sort them based on their minimum value. And then first calculate for each of them what is the maximum below it or above it. And then second, you have to choose something above it and choosing all the upward above it. And then just print the required values. Any questions, anyone? So thanks everyone for joining in today. I think primarily I did created this stream to test out my stream setup for the Blitz contest. I will probably have to tomorrow or day after tomorrow one Blitz Codeforces Blitz Cup match and a couple of practice rounds. So thanks everyone for joining today. And with this, we are done for today's contest.